Expressions and equations. Number 7, we're going to still continue to solve equations with one variable. Learning target 1, part 2, the learning target doesn't actually change. We're still going to solve linear equations with one variable that may require, and we're going to spend more time with combining like terms, and we're going to spend more time with distributive property or doing both. So I have 4 examples today. We'll start with that first example, and we're going to start with one with a fraction. So our example is going to be negative 15 halves plus 9x. And it's going to equal negative 13 halves plus 6x. So you're going to notice the first change in what we've done before is that it's going to have exponents on both sides. So before we only had exponents on one side, now we're going to have exponents on both sides. And so the first thing you have to decide on, which exponent do you want to get rid of first? You can't keep both of them. You can only leave one. So we have 9x and 6x, and I choose, and it doesn't mathematically matter, but I choose always to pick on the little guy or to get rid of the little guy. So in this case, since the little guy is 6x, I'm going to subtract 6x to get rid of it on my right side. If I do it to one side, I do it to the other side. And if you are my person who likes to make your line, go ahead and make the line down. And now I'm just going to solve. So I still have negative 15 halves plus, I'm going to do the math here. If I had 9x's and I'm going to subtract 9x's, I'm going to end up with 3x's. And now that is equivalent to negative 13 halves. Now we can just solve it like we've normally been solving it. And we're going to try to get x by itself here. So we're going to, first of all, get rid of negative 15 halves. So we're going to, since it's negative, we're going to add 15 halves to both sides here. And so we're going to end up here with 3x's because these are inverses of each other, so they cancel each other out. And that equals, well, negative 13 plus 15, we can just add those since the denominators are the same, and that becomes 2. And since the denominator is 2, so we got 2 halves, or known as 1. So I'm just going to rewrite it with 1. And then we're going to divide by 3 on both sides, my third step here. And then x equals 1/3. And the most important thing is take time to check it in. Now, checking in is just a little bit different this time because you notice there's 2 sides of the equation. Before it equaled a value such as 10. Now you actually have to plug it in. So we're going to put negative 15 halves. We're going to add 9 times 1/3. I'm going to put that in the calculator, and my answer is going to come out equal to negative 4.5. And now I have to do the other side of the equation because you want to go back to the original to plug it back in just in case you messed up somewhere down the steps. And I'm going to plug in the other side of the equation, which was negative 13 halves. And you're going to add 6 times that 1/3 because that's what we said x is. And when I put enter, it also equals negative 4.5. And since they both equal negative 4.5, it is correct because of the equal sign. They have to be equivalent. Okay, example number 2. We'll go negative x plus 23 equals 3x minus 17. Again, notice we're just going to deal with having x's on both sides. And mathematically, again, it doesn't matter which one you choose to get rid of, but you have to get rid of one. You can't leave 2 variables on 2 different sides of the equation. So, and you can't combine them like terms because they are on opposite sides of the equations. I know in W10, you were able to combine all those like terms alike, but in this one, you can't because they're on opposite sides of the equal sign. So I'm going to pick on the little guy. So I'm going to add an x. Since negative x is smaller than 3x's, I'm going to add an x. So I get 23 is equal to 3x plus an x is 4x's minus 17. And now I can start solving my problem because I want x by itself. So I'm going to get rid of the subtracting 17 first by adding 17 to both sides. 23 plus 17 is 40. Still equivalent to the 4x. And this canceled out. And now I'm going to divide by 4. Because 4 divided by 4 is the 1x I'm looking for. And I'm going to go back up here, and 40 divided by 4 is 10. So my final answer is x is equivalent to 10. Again, we're going to check. You have to do both sides here. So we're going to start with negative 10 plus 23 equals 13. And now I'm going to start with the other side, the 3x side. So 3 times 10 minus 17. Well, that's 30 minus 17 is 13. Since they both equal the same value, then I know that I have to be right with x equals 10. Third example, and this would be the fifth set when you are looking at your packet or when you're taking the test on this. This would be the fifth set. And so this set has you doing multiple steps. You're going to distribute. You're going to combine like terms sometimes. You're not going to just do one or the other all the time. So start this problem with 7 times 2x plus 5. And then we're going to subtract 6 and multiply that times 4x minus 3. And that's all going to be equivalent to 163. So the first thing you have to do, first step always is to distribute. You have to get rid of your parentheses. So if you think about PEMDAS, parentheses your first step. So I'm going to take 7 times 2x and 7 times 5. So I get 14x plus 35. And then I'm going to take, and be careful with this is a negative 6 times 4, which is a negative 24x, and a negative 6, and I see this as a negative 3. It saves me a step later. So negative 6 times this negative 3 makes a positive 18. And we'll just move down here because it won't let me write it. Plus 18, and that's still equivalent to 163. So if I go back through this, I notice that since I'm still on one side and I still see a lot of terms on this side, I can combine like terms to make this a lot easier of a problem. So I see 14x, I see a negative 24x, I'll deal with that first. That would make, if I add those together, a negative 10x. And then I notice that I have a positive 35 and a positive 18. Well, I can put those two together also to make this a simpler problem. So we call that simplifying. Combining like terms help us simplify the problem. And now notice we have 2 terms left and it equals an answer of 163. So we're just going to solve. So again, I want the x by itself. I'm going to get rid of positive or adding 53 first. So I'm going to subtract 53 from both sides. And I get 110. This crosses out because those are inverses and they canceled. I get negative 10x. I'm going back here. I want to get the x by itself. So this is negative 10 times x. Inverse is to divide by negative 10. And x equals negative 11. And now I'm going to go and check to make sure I'm correct. So to check this one you actually are going to enter that whole entire original into your calculator, but instead of putting x, you're going to put negative 11. So we're going to take 7 parenthesis 2 times negative 11 plus 5 back parenthesis minus 6 front parenthesis 4 times negative 11 minus 3 back parentheses. I'm going to push my enter button, and I'm going to notice when I push that, it does equal 163. So I can guarantee that x is truly negative 11. Our last example for today is we're going to do negative 4x minus 6 times 5x minus 3 is equal to 50x minus 150. So again, first thing you have to do is distribute. Since there's parentheses, be careful, that's a negative 6 that you're distributing. So negative 6 times 5x is negative 30x. Negative 6 times that negative 3 is a positive 18. And then we're just going to pull down all the extra stuff. So notice I just pulled down negative 4x since I haven't dealt with it. And then I pull down the right side of the equation. Now if I'm looking at this, I'm going to see if I can combine like terms to make my life easier. I'll put my line down. There's already 2 terms over here, so there's nothing I can do. But if I go over here, I notice there's 3 terms. So that means that when I look at this, I can put together the x's. I can add negative 4x's plus a negative 30x's together since they're alike, which would make negative 34x plus 18, still equivalent to the 50. 50x minus 150. I'll erase that. It's going a little crazy on me. Okay. Now, again, we look at it. Oh, there's x's on both sides. Can't have that. So I got to get rid of one of them. I'm going to pick on the little guy, which is the negative. So I'm going to add 34x to the left side. If I do it to one side, I have to go over here and do it to the other side. This cancels out. We have 18 equals, add those together is 84 minus 150. And now my goal is to get x by itself. So I see the x. I have to get rid of the negative 150 first, or subtracting 150, which means the inverse is to add 150. So 18 plus 150 is 168, which is equivalent now to, notice those cancel out because they're inverses, 84x. And we're getting closer. We only have one thing left bugging the x. It's at 84, so we're going to divide by 84 because this is multiplication happening between the 84 and the x. So if I divide by 84 on both sides, x is equivalent to 2. Important part is go ahead and check. So I'm going to plug this 2 back in. So I'm going to grab my calculator, and I'm going to start at the original. So I'm going to take negative 4 times 2 minus 6, front parenthesis, 5 times 2 minus 3, and get that answer. And then I'm also going to do the other one, 50 times 2, and subtract 150. So the answer to both of those are negative 50. And because of that, I know that I'm correct.